Greetings! Our universe is brimming with profound questions, paradoxes, and unfathomable events. Just as we depart Earth in a spaceship, or a fish leaves its natural habitat, could we venture beyond the universe in a spaceship? The universe encompasses all that exists, and in theory, there's always a boundary, systems nested within others. Earth within the solar system within the galaxy within the local group, and our galactic supercluster, Laniakea. The universe should be contained within a much larger system. The crux of the matter is that the universe limits us from traveling faster than the speed of light, yet at the same time, space expands at a rate faster than this speed, and even faster as galaxies move farther from us. Physicists believe that if we were to find a way to travel faster than light, the universe would continue to expand at an even faster rate, preventing us from ever reaching its end. It's as if the universe is trying to conceal something from us. It refrains from allowing us to travel swiftly, imposing constraints, yet simultaneously breaks those constraints to expand. The Hubble constant, which indicates the rate of the universe's expansion, has left astrophysicists baffled. The values it yields vary depending on the region being observed and how measurements are taken. Repeated calculations are needed. An international team of astronomers and physicists has once again recalibrated the Hubble constant based on data from the Fermi Gamma Ray Telescope. The new measurement is 67.7 kilometers per second per megaparsec. Prominent figures in the field are attempting to fathom what's happening out there. The universe is accelerating, and this is due to the changing rate of expansion. As our knowledge and technology advance, we realize that the rate of expansion is not fixed. The universe seems to be toying with us. However, these calculations are contradictory, and we've had to recalculate them. We operate well with fixed values to predict phenomena and uncover the mysteries of the universe. Yet, if the constants change, we become disoriented and stagnant. The universe appears to modify itself at will, contingent on the observer and their location. It doesn't want to unveil what lies beyond and what secrets it holds. If I were the creator of the universe or a programmer designing such intelligent beings that would recognize the universe they live in and contemplate leaving it, I would certainly set limits. My creatures have evolved, but they can never leave my universe, and the best way to do this is by creating a dynamically self-generating universe that reacts to observers and changes. This would drive them crazy, much like it happens to us. Perhaps one day, we'll create characters so sophisticated that they attain self-awareness, stand up to us, and desire to break free from their contained universe. After all, universes are systems within others. We, too, design universes, though not yet at such an advanced level. Leaving these questions for later, let's return to the universe we know. Since we're currently incapable of traveling vast distances, all we can do is gaze at the sky through our instruments. The limit of the speed of light not only prevents us from traveling very quickly wherever we wish, but what we see in the night sky isn't in real time. It's in the past because the light from objects takes time to reach us. In other words, we cannot create maps or plans on a universal scale. We can only see about 13 billion years back in time. This is what we call the observable universe or visible universe. The light has only traveled 13.8 billion years since the universe became transparent, and it's not real because it comes from the past. The universe has been expanding ever since the Big Bang, so its current size is about 93 billion light-years in diameter and with a flat geometry, according to recent data. For example, the light reaching us from the Andromeda galaxy isn't seen in the present. We see it as it was over 2 million years ago. The universe even deceives us in this way. Nothing is in real time. The limit of light prevents us from traveling, and, as if that weren't enough, the space containing us expands even faster. In another sense, we cannot communicate with our extraterrestrial neighbors in real time, always within our galaxy. For now, we don't know of anything that conveys information faster than light. Thus, if we were to send messages to distant galaxies at the speed of light, since the universe expands faster than light, those messages would never reach them. We are isolated from the rest of the universe. The limit of the speed of light and the variable Hubble expansion rate constrains us. It's a clever attempt to confuse us, but we are too curious to give up. We find ourselves aboard a spaceship, eager to exit the universe. We know that the universe is in constant motion, nothing is static, and the spacecraft, in the vicinity of Earth, moves with the sun, the galaxy, and everything else. The secret lies in outpacing the universe and its rate of expansion. We move not only at a speed through the universe, but the very fabric of spacetime also carries us away from the farthest galaxies. We don't know what the center of the universe is, any point could be it. We would need to surpass the speed of light and, simultaneously, the universe's rate of expansion to reach its limits. Einstein's theory of relativity tells us that no object with mass can exceed the speed of light. The only solution for our spaceship is to modify the fabric of spacetime itself. This is what's known as the warp drive. It's theoretically possible, but currently, according to NASA, it's far beyond our technological reach. The explanation is simple. It involves bending spacetime to arrive at the destination sooner. And to do this, a warp bubble must be created. Imagine a point on a piece of paper. That point is our spaceship, and another point is another star. Instead of traveling in a straight line, we fold the paper so that both points come together. A portion of space is folded, allowing us to arrive at the destination sooner. The warp bubble prevents the strange phenomena of relativity, such as time dilation, where we age slower than those on the ground. Miguel de Alcubierre suggests that strange matter or negative energy is needed to create the warp bubble. Richard K. Abausi and Gerald Cleaver from Baylor University, Texas, believe that moving a large ship of a cubic kilometer would require energy equal to Jupiter's mass, and the speed could never be higher than 10 to the power of 32 times the speed of light. With the warp drive, we would need to navigate far, always within our galaxy. However, traveling to other galaxies and reaching their limits would require more energy than what's contained in the universe. Currently, some NASA scientists are working on a small-scale warp drive. Another solution would be to come to a sudden stop and let everything else move ahead to exit the universe. The challenge is that we're stuck, like ants in gum, and spacetime drags us along, even if our theoretical speed were zero. There's no practical way to travel to the end of the universe, but we can make certain calculations and speculate about what's on the other side. According to Sean Carroll, a research professor in physics at Caltech, there might be no limit in the universe. It either continues infinitely or folds upon itself. Beyond the observable universe, there are more galaxies and galaxy superclusters that we'll never know about, as light hasn't had time to reach us due to the universe's expansion rate. Some believe that there are various edges in the universe. The first would be the observable, visible universe, and the other the non-visible universe. In one of his last revolutionary theories, Stephen Hawking stated that the Big Bang is incorrect and the universe has limits. The expansion rate varies at different points in the universe. There are regions where it has halted and others where it continues indefinitely due to quantum phenomena. While we perceive global expansion, it's merely an optical effect. We would be in a hospitable part of the universe, a region where expansion has stopped and galaxies and planets are forming. The universe is composed of various edges defined by string theory and consists of three-dimensional spaces defined as a complex hologram. The universe originated from quantum phenomena, and clear limits may not exist. Instead, different states emerge as we progress, changing conventional physical laws, and we would need to abide by quantum phenomena. A spaceship theoretically exiting the universe would evaporate, and its particles would disintegrate, as the four fundamental forces we know would disappear, and atoms would split. Outside, there's nothing that our physical laws can measure. Black holes are theoretical exit gates of the universe, where physical laws cease to function. We already know what would happen if we crossed one. We would disintegrate. We are the universe itself, composed of overlapping energy and gravitational fields. There's no logical escape from these fields. Much like a character can't leave a video game, it's composed of bits of information forming the program that sustains it. It can't exit the computer. There's only one way to exit the universe, and it wouldn't be in a warp distortion bubble, but by creating a miniature bubble of our universe that also contains our spaceship. With highly advanced technology, it might be possible to carry our universe with us and exit it even without physically moving from where we are. And what would we see exactly if we're not a simulation? Leaving the universe would render the known physical laws non-existent and different. Photons wouldn't reach us, and we wouldn't see anything. Perhaps with a sophisticated apparatus based on these new laws, we could begin to see structures or shapes that would bewilder us. It's believed that other universes or multiverses exist, some similar to ours, others vastly different, contained within a quantum foam like bubbles. Carrying spacetime with us could create disruptions in the quantum foam. The culmination of our journey defies imagination. In regions where laws cease to make sense, even light, which is beyond time and has infinite speed from the photon's perspective, can't escape the universe, as it's governed by laws that permit its existence. What's known for sure is that there's no exterior of the universe, simply because it can't be defined by our laws. It can't even be calculated. We can't exist outside of this. We require dimensions, universal laws that prevent us from disintegrating, and time to live. We must be content with studying a small part of the observable universe, increasingly isolated from the rest, a universe that continues to bewilder us, allowing us to live and deceiving us, enveloped in the deepest mysteries. If you enjoyed this video, please like and subscribe, share on social media, and leave your comments.